Okay, so lesson 5, infinite geometric series and problem solving. We just watched a video, the TED Ed video, and we saw that if we were to find the sum of this, it is possible, right, with each step. And what was the sum? Yeah, sum infinity was 1, that Zeno will take 1 hour to reach there, the wall. Okay. This was an example shown in the video already. So if you were to look at the shape and see if it'll actually be ever fully colored, you can split it into half, color that part, split it into half, color that part, another split, another split, another split, another split, another split, another split, another one, and then eventually everything will be colored. So if we were to think of this, it'll take infinite time for it to be covered. Okay? But the area would be 1, right? Because the whole thing will be covered, but in infinite time. Okay, so the key terms from this lesson is convergent series, which means that a series that is approaching infinite number of terms. So as the number of terms increases, the sequence of partial sums also increases. So they approach a fixed value. Okay, this can only happen if the common ratio is between -1 to 1, just like 0.5 in Zeno's case, right? So if we're looking at 4, 2, 1, 0.5, 0.25, is this an arithmetic series or geometric? Geometric, because the ratio is for that 0.5. 2 divided by 4 is half, or 0.5. So it's going down by 0.5 or multiplying itself by 0.5. So if we do that using a calculator, 0.25 times 0.5 is 0.125. Times 0.5 is 0.0625. Keep going, it'll be 0.03125, then 0.015625, 0.0782125, 0.00390625. And all I did to get there is just multiply the last term by 0.5. Okay. So remember, your ratio, like convergent series, are the one where a fixed value is reached, right? And it's between -1 and 1. So your ratio needs to be in between this range. Okay. So if the pattern continues forever, what happens? Like in this case, if it keeps multiplying by 0.25. Cut in half, which means the term would be, like, it'll get smaller, right? The value will get smaller every time. And because it'll get smaller, eventually it will reach a certain value, right? The next term we have is divergent series. So convergent, the ratio is between -1 to 1, right? And gets smaller and smaller and eventually reaches a certain value. When we talk about divergent series, it is also infinite number of terms, and the number of terms keep increasing, so it continues to grow, and it does not reach a fixed value. Okay, so you cannot calculate the sum in this case. Like for 2 we were talking about, you won't be able to. So there is another example given to us, and for divergent series, the ratio needs to be either below -1 or above 1. So r is less than -1 or r is greater than 1. So it's going up by 2, multiplied by 2, right? 32 times 2 is 64. 64 times 2 is 128. Times 2, 256. Times 2, 512. 512 times 2 is 1024. Times 2 is 2028, and so on. So, sorry, 2048. So, if this keeps on going forever, what will happen to the value in each term?
Get bigger every time?
It'll get bigger, right? Increase every time. And what will the sum of the value of all these terms be? Infinity, because eventually the numbers will keep bigger and getting bigger and bigger and bigger, and when we add it, it'll just reach infinity. Okay? So we can only find the sum of those infinite geometric series in which the ratio is between -1 and 1. Okay, if an infinite series is given to you and the ratio is either above 1 or below -1, it's not possible to find it. The answer in that case would be when the ratio is bigger than 1 or less than -1, the answer for the sum would be infinity, right? So we know the formula for the sum of geometric series is this, right? If r is a value between -1 and 1, then as n gets larger, the value of Rn will be smaller. It will be very small and eventually approach 0. Okay, so that's why we can, in this question, we can replace Rn to 0. So T1 times 0 minus 1 over R minus 1. We only converted this to 0 because it has n, which keeps getting bigger and bigger. That means we have t times -1 over r minus 1, which is -t over r minus 1. Or if I factor out negative from my denominator, right, I'll have -t over -1, -r plus 1, right? And then I can cancel the ones and I'll get t1 minus r. So you can either use that or this. Okay? So this is the sum when you're given a geometric series that has infinity as its number of terms. Questions? This formula is also given to you in your formula sheet. Okay. So let's do a few questions. So it's given to us that there is a series that's starting at 2, then -2 over 3 plus 2 over 9. T1 is? T1 is 2. Ratio will be? -2 over 3 over 2, because Tn over Tn minus 1. So we have -2 over 3 divided by 2, which is just -2 over 3 times half. Keep, change, flip, right? This cancels and we have -1/3. Okay, so that's our ratio. Now, how can we tell if this is convergent or divergent? Convergent is when the ratio is between -1 and 1. Is this between -1 and 1? Yes, so it's going to be convergent. Now, because it's convergent, we can find the sum for this using the formula given to us. So S infinity is T1, which is 2 over 1 minus -1/3, which is 2 over 1 plus 1/3. And when we solve that using a calculator, you'll get 1.5 as your answer. That's your sum. Let's do the next question. T1 is 2. Ratio is -4 over 2, which is -2. Now, is -2 in between -1 and 1, or is it bigger than 1 or less than -1? It's less than -1, right? That means it's divergent, right? Can we find the sum for this? No, no sum exists. Okay, try part C and D, and then we'll move on to the application question. So for part C, T1 is 4. Our ratio would be 1.5, because 6 divided by 4 is 1.5. Since 1.5 is greater than 1, it will be divergent. So no sum exists. T1 is 1. Ratio is going to be 1/2 over 1, which is just, 1/5 over 1, which is just 1/5, and that's 0.2. Now, that means this is between -1 and 1, so it's convergent. And then we just put it in the formula. S infinity is T1, which is 1 over 1 minus 0.2. That's 1.25. Okay. So when you put it in the calculator, do 1 divided by, bracket starts, 1 minus 0.2. Okay. Questions? Okay, let's do the application question. In the diagram shown below, a square is being divided into quarters, and each time one of the new squares gets shaded, assume this pattern of quartering and shading continues indefinitely. Write the series of terms that would represent the shaded part. So we're starting off with, when we cut it into half and shade the first part, what would the shaded area be? 1/4, right? Because this wouldn't be shaded at all. It would just be the blue part over here, which is 1/4, right? The next time we do that, it's going to go down by a quarter, right? Yes, room 175. Okay, so 1/4, and then it's going to go down by 1/4 again, which would be 1/16 plus 1 over 64 plus 256, because 64 times 4 is 256. And then 1024, and so on. It's gonna go and go and go, right? So let's figure out if we can solve this question or not. We have T1, which is 1 over 4. We have our ratio, because the pattern of quartering is going to be 1/4 as well, right? That means 1/4 is 0.25, and that is in between -1 and 1. So what we'll do is we'll use the sum of infinity terms. T1 over 1 minus r, which is 1/4. Put that in the calculator. What do we get? When you put it in the calculator, make sure you do this. 0.3 repeating, and that's our answer. Okay. not that tricky, right? All you need to do is figure out if it's infinite or not, if it's geometric or not, if the ratio is in between -1 or 1 and 1, and then use the formula. This whole lesson is about just using formulas after you find T1, N, and R, right? Or D. Okay, try this question and then we'll discuss it. Okay, so for this question, one side of the square is 12 centimeter and the midpoints of its sides are joined to form an inscribed square, and this process is continued as shown. So this is 12, right? That means this is going to be 6 and this is going to be 6 till here. This is 6 as well. So we use Pythagoras theorem, right, to figure out what this value would be. So 6 squared plus 6 squared is equal to x squared. Let's say 36 plus 36, square root of that is x, which will be 72, right? X is equal to square root of 72. So we're starting with 12 and then we go down to 72. 72 can be written as 9 times 8, and that 8 can be written as 4 times 2, where 9 and 4 are perfect squares. So it'll be 3 times 2 root 2, okay? 3 times 2 is 6 root 2. Let's do the same for the next one. Let's figure out what that would be. So square root, this side right here would be half of 6 root 2. Half of 6 root 2 is? Six divided by 2 is? 3, so it'll be 3 root 2, right? And then this will be 3 root 2 as well. We can figure out this length, which would be 9 times 2, because 3 squared is 9, plus 9 times 2, square root of that, which will be 18 plus 18, square root of that, which is 36, and that's 6. So our first 3 squares, the side lengths will be 12, 6 root 2, and 6, okay? The parameters now, perimeter of a square is 4 times the side, so 12 times 4 is 48, 6 root 2 times 4 is 24 root 2, 6 times 4 is 24, okay? So to figure out the common ratio, R will be root 24 over 2, 24 root 2 divided by 24. Our common ratio is just root 2. Oh, I did it the opposite way. It's going to be the bigger term first, so it will be 24 divided by 24 root 2, which is 1 over root 2. You never keep your root in the denominator. So how can we rationalize this? That would just be the exponent, root 2 to the power of -1. But how can we not have the square root in the denominator? When we rationalize, we multiply both numerator and denominator by root 2, right? Because root 2 times root 2 is? It's root 2 squared. Squared times square root is just 2, right? So we have root 2 times 1, which is root 2, divided by 2, okay? So that's how you leave your answer at. Now, we need to figure out the sum of the parameters of the square. So T1 is 48. So sum infinity is going to be T1 over 1 minus R. T1 is 48 over 1 minus root 2 over 2. So we'll solve the denominator first, which will be 48 over, make 1 have the same denominator as root 2 over 2, which will be 2 minus root 2 over 2. So that will be 48 over 2 minus root 2 divided by 2. Now, because it's being multiplied, this is where the division is happening. So it'll be 48 divided by 2 minus root 2 over 2. Keep, change, flip. Keep 48, change the multiplication sign, flip the second fraction. We have this, which is just 96 over 2 minus root 2. Can we keep 2 minus root 2 in the denominator? No, we'll have to get rid of that. And to get rid of that, we'll have to rationalize. So multiply both numerator and denominator by 2 plus root 2. Okay, so when we do that, it'll be 96 times 2 plus root 2. And then let's distribute these two things, which will be 2 minus root 2 times 2 plus root 2. 2 times 2 is 4, plus 2 times root 2 is 2 root 2, minus 2 root 2. Root 2 times root 2 is minus 2. So 2 root 2 minus 2 root 2 is 0. 4 minus 2 is 2. So our denominator has 2 now. 96 divided by 2 is? 48. So my final answer will be 48 times 2 plus root 2. Distribute that. 48 times 2 is 96 plus 48 root 2. And that's my answer.